Today we're going to cover chapter 2.3, which is Radian Measure. Okay, I'm just going to dive right into page 53 of your Discovering Mathematics textbook. What is a radian? So basically, if you know, alright, like in Singapore and maybe in UK, we actually use things like cm and inches. Cm, sorry. So actually use cm. So in other countries like America, they actually use inches. Both of them actually relate to length. Okay, so one is in cm, one is in inches. Similar idea. Okay, so when we think of angles, we actually think in terms of degrees, but there is another unit that I'm going to teach you today. It's called radians. So both of these units will actually deal with angles, okay, and how large angles are. So you can talk about it in degrees, you can talk about it in radians. So what is a radian? So just imagine, okay, you have a circle, as you can show down here. Okay, first and foremost, if you have a radius r, okay, so if you take the radius r, okay, imagine just take this r, and it's like a piece of string, okay, and you can lay it out. All right, so if I lay it out on the circumference of the circle, so just now I took this piece of string there, I lay out down here. So in this case, if the arc length is r, okay, the angle that is formed in this case will actually be 1 radian. Okay, so that's how we actually measure how large, so to speak, 1 radian actually is. Okay, so basically, if we see, right, actually by definition, okay, how to convert, like, between cm to inches, there's a way to convert. So between radians to degrees, it's actually quite easy. Okay, it's actually pi radians equals to 180 degrees. So whenever we talk about radians, if we just need to know pi radians, okay, is equals to 180 degrees. And this is proportional. Okay, if you notice, I've written here pi over 2. So if I want to quickly convert, if from pi to pi over 2, I've divided by 2. Similarly, 180 degrees, I divided by 2 here. What I should get is pi over 2, the radians equals to 90 degrees. Now, I'm just going to write down another one. I will start from here. I say pi over 4 radians. If it's by proportion, can you tell me if pi radians is 180 degrees? So from here to here, I divide by 4. So similarly, 180 divided by 4, the conversion is simple. Pi over 4 radians actually gives me 45 degrees. Take a short moment now, think about it. What is pi over 3 radians? Now you'll notice that it will actually be 60 degrees. All right. Okay, now I'm going to just quickly move to try it 9 on page 55. So we're going to do a bit of exercises here to convert, right, between radians and degrees. So I'm just going to start with the two angles here. So first I remember from the previous page that pi radians equals 180 degrees. I write it the other way around, is 180 degrees equals to pi radian. So if I want 135 degrees, what I can actually do here is this. I actually can try to find what 1 degree is. So if I divide by 180 on the left, I will also divide by 180 on the right. So essentially, what I get is 1 degree is pi over 180 radians. Then if I want to get 135, I just multiply by 135 on both sides. I'll get pi over 180 times 135 radian. So what you can do here is this. Just key into your calculator. What is 135 divided by 180? You'll find that you get 3/4. So hence, I can say that 135 degrees is equals to 3/4. Don't forget the pi is still there. So it's 3/4 pi radians. Similarly for part B, alright, I will just start from here. So 1 times 210. So 210 degrees equals to pi over 180 times 210 radians. Similarly, if you use your calculator, you find that 210 over 180 will give me 7 over 6. Hence, in this case, it will give me 7 over 6 pi radians. So if I talk about 135 degrees, the size of the angle is same as 3/4 pi radians. 210 degrees is 7 over 6 pi radians. Alright, then now they say in try 10 on page 56, express the following in radians. So once again, I just bring you back to the idea that 180 degrees is equals to pi radians. So if you can see down here, okay, I will go back to 1 degree is equals to pi over 180 radians. So 45 degrees, I multiply by 45 on both sides. So what I'll achieve here, if you key the calculator, so you just take a calculator, you take pi over 180 times 45. In this case, we will just multiply pi in. Then the result that you should get is, correct, the 3SF is 0.785 radians. So here I say this is 0.785 radians. So similarly for part B, if 1 degree is pi over 180 radians, so I'm looking for 200 degrees equals to pi over 180 times 200 radians. So just key into your calculator this value over here, and what we'll get here is 3.49 radians. And still on page 56, I am on try 11 now. So 7 pi over 4 radians. So in this case, if you recall, alright, we know that pi radians is equals to 180 degrees. So how do I get 7 pi over 4 radians? I can just multiply by 7 over 4, and I multiply by 7 over 4 in this case. So what I'll get here is 7 pi over 4 radians equals to 180 times 7 over 4. So in this case, what I get is 315 degrees. Okay, part B may not be that simple a conversion because it's 4.7 radians, but not to worry. So I start with pi radians is equals to 180 degrees. Now, to get to 4.7, first and foremost, I need to find what is 1 radian in terms of degrees. So I divide by pi and divide by pi. So what I get is 1 radian equals to 180 degrees over pi. And now if I want 4.7 radians, what I'm essentially doing is multiplying by 4.7 on the left, and I multiply by 4.7 on the right. So I get 180 degrees over pi times 4.7. So what I get here is 3.49, sorry, so 3.49, what I get is 269.3. So what I get is 269.3 degrees, correct to 1 decimal place. Okay, now what I need to do is this: when we use, whenever we do calculations in radians and we are dealing with sine, cosine, and tangent, what I need to do is to change my calculator mode from degrees to radians. So if you look at a calculator, how we do that is we need to change the mode. So we just press shift time and then we press set up. So once we go to shift and set up, it brings us to this menu screen here. Then what I want to do is to press the number 4 to get radians. Then if you have done all the steps correctly, you look at your screen, there should be this small little R there. So this is R inside the box there. It means that your calculator is now in radian mode. Okay, similarly, now if let's say I have already worked on radian mode already and I want to change my calculator back to degree mode, same thing. What I do is I press shift and I press set up. Okay, this brings me to this menu over here. Degree mode is number 3. Okay, degree mode. Then you'll notice your calculator is back in degree mode. So here what we'll get here is the letter D will denote that your calculator is in degree mode itself. So now we have this. Okay, so go on ahead now. If your calculator is already now in degree mode, what you can do is to change your calculator back into radian mode itself. Okay, then if it's in radian mode ready, let's just try it 12, alright, and just key in these two values, tangent pi over 4 and sine of 1.3, as I've shown on my screen here. So what you should be able to get for tangent pi over 4, if you key in, if your calculator is in the correct mode, they will give you the value of 1. Similarly, if you key sine of 1.3, you should get the value of 0.964. Please try to key this in your calculator to see that you actually get the correct values. Okay, I'm on page 57 now. Alright, so again, find the angle theta in radians. So be careful, ensure that your calculator is in radian mode. So I will do part A first. Cosine theta is equals to 19 over 27. To actually get the angle theta, I will take inverse cosine of 19 over 27. And if all is done correctly, the calculator should give you the value of 0.790 radians itself. So if I look at part B, similar idea. If tangent theta is equals to 1.386, theta itself is inverse tangent of 1.386. And you try with your calculator, what you should get is 0.946 radians itself. Now, I'm just going to do some examples from the exercise 2.3. So I will just delve right into question 7, which can be found on page 58 of your Discovering Mathematics textbook. So they say this: in triangle ABC, BAC is equals to pi over 3, ABC is pi over 4, find ACB. So, okay, so in a triangle, we know that for a triangle, angle sum of triangle is 180 degrees, okay? And in this case, if 180 degrees, right, is how many radians? If you recall from the earlier part of the lesson, 180 degrees is equals to pi radians. So in this case, if I have two angles ready, the third angle, I want to find ACB, I'll take pi, which is the angle sum of triangle. Let me just write it down here. Angle sum of every triangle, okay, pi radians, minus pi over 3 minus pi over 4. Okay, so here what I'm actually doing here is this: I'm taking 1 pi minus 1/3 pi minus 1/4 pi. So if you just key into your calculator, I'll get 1 minus 1/3 minus 1/4, and the calculator will give you the value of 5 over 12. So 1 pi minus 1/3 pi minus 1/4 pi will give me 512 pi radians. Okay, I am coming now to the last question of chapter 2.3. This can be found on page 59 of your Discovering Mathematics textbook. Okay, so first and foremost, the diagram, okay, you can read the question by yourself. So they want us to find the angle BAC. So what's so special about this triangle? If you notice, AB and AC have the same length of 5. So therefore, this is actually an isosceles triangle. So just like the previous question, we know that the angle sum of triangle is pi radians. So now I will say that angle BAC is equals to pi, which is the angle sum of triangle, minus pi over 6 minus pi over 6. So what I'm actually essentially trying to find is 1 pi minus 1/6 pi minus 1/6 pi. So if I key this into my calculator, 1 minus 1/6 minus 1/6 will give me 2/3. So angle BAC is actually equals to 2/3 pi radians. Now, I will look at part B, the length of AD. So since we are dealing with a right angle triangle, I can apply the trigonometric ratio. Okay, so I'm trying to find the length of AD here. So with respect to this angle, this is the opposite, and I also have the hypotenuse here. So this is the opposite, this is the hypotenuse. So opposite and hypotenuse, what I can actually use, alright, will be a sine ratio. So I will say this, I'll say that sine of pi over 6 is equals to opposite over hypotenuse, which is AD over 5. So my AD value is, okay, the 5 will multiply here. So I get is 5 sine of pi over 6. Just try to key this in a calculator. You'll find that your length of AD is 2.5 meters exactly. Now for part C, the space enclosed within the rooftop. So the space enclosed within the rooftop is basically the area of the triangle. So what I can say is this, the area of triangle, area of triangle ABC is equals to half AB sine theta. What is theta? 2 over 3 pi, 2 over 3, yeah, 2/3 pi. Just key that into the calculator. You'll find that you will get a value of 10.8 meters square. And this concludes the lesson on 2.3.